Hello friends, today in this video we will be discussing some important questions. They were asked in A-level physics in 2016 from electricity. Let us see this first question. In this question, this ABCD are the path of electron and they are entering in a uniform electric field. The direction of electric field is like this. It means upper plate is positive and lower plate is negative. As electrons are negative, they are negative charge, so they will move towards positive plate. So A and B are moving towards positive plate. So C and D cannot be answered for this question. Among A and B is the straight line and A is the curved line. Path of electron in electric field is parabolic or a curved path. Because of that, our answer choice for question number 30 is A. Now let us move to question number 31. In this question, we are given 4 charges. The 4 charges are at the corner of a square, and the x is the electron. Here x is electron, and we need to identify what is the direction of force at x the electron is experiencing at x. As electron is at x, so its field direction for force should be towards positive plate, towards positive charge. So our answer can be A and B, but the direction of force in a this line of force or force line is shown by a tangent. Here B is a tangent, so our answer for question number 31 is B. Now let us move to question number 32. In this question, we are given here 2 plates. This one is the lower one is at minus 80 volt, and the upper one is we don't know the potential or voltage of upper plate. The potential, the electric field is 60,000 volt in between this plate, and its direction is upward. The separation between those 2 plates are 4 mm. Now let us see the calculation for this question. The provided electric field E is equal to this. Our D is 4 mm. Because of that, the potential difference between these 2 plates will be 240. The potential difference between these 2 plates is 240. Lower plate is already at minus 80 volt. So our upper plate can be either at minus 80 plus 240 volt or minus 80 minus 240 volt. On solving this, we will get either minus 320 or plus 160 volt. As 240 is potential difference between these 2 plate and lower plate is at minus 80 volt. Because of that, our answer can be minus 320 volt or plus 160 volt. If we see our question, the direction of electric field is upward. Upward means the lower plate should be at higher potential and upper plate should be at lower potential. If we compare minus 320 and plus 160 volt, this minus 320 is lower potential. Because of that, our answer will be minus 320 volt. If we see our option choice, we have both option here, minus 320 as well as plus 160. Our answer is minus 320 volt because of this upward direction of electric field strength. Now let us move to question number 33. In this question, we are given a kettle with power this and volt this. Now we know that formula P is equal to I into V. On solving this, we will get our current 12.9 and 12.9 are there in B and C and D. Now we know that B is equal to IR. Our V is already there, and we got our I. Now on solving this, we will get our R will be 18.6. Then our correct answer will be option choice C. Option choice C is the correct answer for the question number 33. Now let us move to question number 34. In this question, here is one thick copper wire and here is one thin copper wire. Now what is the significant less in thick wire than in thin wire? In thick wire, we need to find what value is less. Charge passing will be more in thick wire. The drift velocity, we know that I is equal to VENA. if we see the relation of drift velocity and area, they are inversely proportional with each other. So if area is less, then drift velocity will be more, or if area is more, drift velocity will be less. So here area is more in thick wire, because of that the drift velocity is less. Because of that our answer is answer choice B. Answer choice B is the correct answer for question number 34. Because of more area, the drift velocity will be less in thick copper wire. Now let us move to question number 35. What is the typical value of order of magnitude of resistivity of copper? We know that resistivity of copper is in the order of 10 to the power minus 8 ohm meter. For this, let us see this table. In this table we have the resistivity. Resistivity is generally in the order of 10 to the power minus 8 for aluminum, copper, gold, iron, silver and tungsten. For nichrome and copper, it is in the order of 10 to the power minus 6 and 10 to the power minus 5. If we do reciprocal of resistivity, we will get the conductivity. So our correct answer is for copper 10 to the power minus 8 ohm meter. Now let us see question number 36. In this question, the reading of emitter is 0. It means that R1 and R3 must be at same potential, and R2 and R4 must be at same potential. This is so easy one. Now we will use the principle of potentiometer to find what is the potential at R1 and what is the potential at R3, and if we equate that, we will get our answer. Or else we can equate the potential of R2 and R4. Now let us see here the using the principle of potentiometer. Potential at R1 is, if the EMF of battery is E, then in this branch, if we see in this branch, in this part, the potential at R1 will be R1 divided by R1 plus R2 into E. Similarly, potential at R2 will be R2 divided by R1 plus R2 into E. Similarly, in R3, R3 divided by R3 plus R4 into E. Similarly, in R4, this will be this. Now, if we compare the potential of this R1 and R3 like this, if we compare, if we equate them, because if the potential are equal, then only this emitter, if the potential of R1 and R3 are equal, then only the emitting of emitter will be 0. Or we can compare, we can equate the potential of R2 and R4 as well. Now on doing on equating the potential of R1 and R3, we get this relation. This relation is in our option choice D. So our correct answer for the question number 36 is option choice D. Now let us move to question number 37. In this question, we are given 4 different nodes, and in this node we can use Kirchhoff's first law or Kirchhoff's current law. According to that law, at node, incoming current should be equal to outgoing current, and Kirchhoff's first law is based on conservation of charge. If we see this node, in this node incoming current is I1 and outgoing current are I2 and I3. That is, I1 should be equal to I2 and I3. I1 should be equal to I2 and I3. That is in option choice A. So our option choice A is the correct answer for question number 37. Thank you very much.